Hello, this is AMET 104, lecture recording week 3.1. So today we're going to go over the financial mathematics. So up until last class, we talked about the sequence and different growth models and how it's used in real life situations. And all those would be very applicable when it comes to financial mathematics. So before we start, let me read a little paragraph from the textbook for you. So according to the textbook, 60% of the US adults neither have a budget nor keep track of their spending. And 64% of the US adults do not understand how compound interest works. And 33% of the US adults carry some credit card debt from month to month, and 6% admit to having been late making late car payments. 45% of the working age US households have no retirement savings at all. And the median retirement savings account balance among all working age households is only $3,000. And 75% of the US adults agree that they could benefit from advice and answers to everyday financial questions. So what does this tell you? So this tells you that not many people really know about how money works. We know money buys things, but not many people really understand how the savings, debts, all these things work. So this entire chapter, chapter 10, is to basically go over the basics and learn about different types of savings and debts and also financing as well. So of course, in real life situations, a lot of the times, a bank would do it for you, but it'll be very beneficial if you understand how everything works, so you can plan everything ahead and make smarter decisions rather than just jumping into things without knowing anything. So today is actually going to be a little shorter than usual class, because today we're going to talk about something very simple, and I'm sure a lot of you already know how to do this. So today we're only going to do the percentages. So percentage is, let's say, a fraction with denominator 100 can be interpreted as a percentage. So that was quite simple. And the percentage symbol is, as we all know, is that, and we've already been using it. And it is used to, so this is actually used to indicate that there is a hidden denominator 100. So for example, we can see when you say some number x percentage, this implies it's x over 100. Or x here can be any number. So for example, if you have, let's say, 70%, and that's exactly the same as saying 70 over 100. And that's all there is to it. So percentages are actually used in several different ways. So let's look at some examples. So examples of the percentages would be, let's say, you do fees a lot of the fees are percentage based, and tax is also percentage based, and what else? Tips. You also pay according to how much you ate, so it'll be percentage based. And this is also useful when it comes to when you're trying to understand how things increase or decrease. So how things increase and decrease. Relative to some given baseline. So this would mean something like if it has, let's say 20% sale for the next week, how do you calculate that knowing the original price? Or if it has 2% increase in your monthly rent, things like that, we can always calculate the future value, the value that we have to pay in the future, knowing the percentage increase or decrease relative your baseline. So that's really it. That's really it for all these different concept of percentages. That's all you really need to know. But just so you are used to the concept and how it's used, let's go for a few examples. So example. So suppose in your, let's say in an English class, in your English literature class, you scored for the quiz 1, let's say for the quiz, you received 19 out of 25. And on your midterm, let's say you received 49.2 over 60. And in the final, you received 124.8 over 150. So suppose those are your score. None of them are really over 100. So tell me what you did the best. So did you do the quiz the best, or midterm the best, or the final the best? Obviously, if you just look at the numbers, final has the highest number. It has 124.8 as opposed to 49.2 for midterm and 19 for quiz. So can you safely assume that you did the best in the final? So these numbers that you see on the top, the numerator, is actually called the raw scores. So in this case, 19, 49.2, and 0.8. These are all raw scores. And you see that 19 is out of 25. And you really cannot compare this score to, let's say, the final, which is out of 150. So how do you really determine in which assessment that you did the best? So that's where the percentage comes in. So let's convert each of your assessment into percentages. So for your quiz, you received 19 out of 25. You can see that if you multiply 4 on top and the bottom, this is actually 76 on the top and 100 in the bottom. So this would be the same as saying you actually received 76% in the quiz. Another easier way to go about this without really incorporating this 4/4 is you can simply do 19 divided by 25 and plug in the calculator, and that'll actually give you this number. For your midterm, you received 49.2 over 60. And simply by plugging in the calculator, you should receive something like 0.82. And what does that equate to? That equates to 82%. In the final, it says that you receive 124.8 over 150. And by plugging in the calculator, you should be able to see that this is actually 0.832. So that is the same as saying 83.2%. So yes, in this case, in fact, you did do the best in the final, and you got midterm and the quiz the worst. However, given any questions like this, it is always important to measure in the same category. So in this case, just by looking at these numbers, it's really hard to tell which is the largest number, which is the smallest. But if you change everything to percentage, it is really easy to see which is what. So let's look at another example. So let's say you ate at a restaurant with a friend, and suppose that the final bill, let's say the final bill at a restaurant came out to be, let's say $50. So you ate $50 worth of food there. And your friend suggests that you need to tip, let's say, if you want to tip 3/20 of the bill. I know this is ridiculous. Nobody says this, but for the sake of the problem, let's go with this. Let's say your friend suggested that, oh, you should tip 3/20 of the bill. So how much tip is that? How much do you intend to pay for the tip? So usually when we tip, we talk about the percentage. We say 10% of the total bill, 15% of the total bill, 20% of the total bill, like that. So if you simply calculate this is the same as saying, so 3/20 is actually the same as 15% of the total bill. And this can be found by simply putting in the calculator or trying to make the denominator 100. Excuse me. So that's 15% tip of that $50. So let me quickly calculate how much tip that is. Okay, so to find the 15% of the $50, what you have to do is the tip amount, you multiply the original bill by the 15%. So in this case, 7.15. So this has to be in decimal. And you should actually end up with $7.5 tip. So here I'm assuming that all of you understand how the fraction to percentage to decimal works. So I'm assuming that going through high school, you should all know this. But if you are having trouble understanding this, please practice. And if you really need help, please contact me for help. But this is really simple, and I really hope that you guys all understand what's happening here. Let's look at the next example. So let's say you're looking to buy an electronics, let's say an Apple Watch. Let's say you're trying to buy an Apple Watch. Or anything, doesn't matter. This is just for the context. And two different stores. So let's say store 1, and there's also store 2 that actually has it under different price. So let's say in store 1, they say that the Apple Watch, you can buy the Apple Watch for $300. But you also need to take into consideration that there is the 8% tax that you have to pay. In store 2, let's say they had it for $313, which is clearly more expensive. But the store has 5% discount. And also take into consideration that you still have to pay the tax. So which one of the two stores is better? Sure, it may actually be a very small amount of difference. So, but for the sake of the problem, let's say that you're looking to buy one cheaper, even if it's only $1 difference. So if you look at store 1, it's very cut and dry. It's very simple. The price is $300, and after you pay tax, you just walk out of the store. At store 2, it's $313, which is more expensive, evidently, than store 1, but you have a 5% discount coupon, or the store is running a 5% discount credit. Whichever it is, you're getting the 5% discount. Obviously, in the state of New York, you still have to pay 8% tax. So if you do not understand how all these calculations work, the only way you can find out is you simply go into the store and just purchase it or ask the representative there, which will be very time consuming and also might end up leaving you with a more expensive option. So let's do some math. Let's do some calculations. So if you have $300 for the Apple Watch itself and 8% tax, so how much is the tax here? So here you should multiply. To find the tax, you're simply multiplying the total price by the 8%. Make sure you put this in decimal, so it is actually multiply 0.08. And that is actually $24. So when you're buying this $300 Apple Watch, you're actually paying $24 additionally as tax. So here you're adding $24, hence the total price that you pay is $324. So now let's look at store 2. So store 2 first offers 5% discount. So what's the discount amount? How do you find the discount amount? So in this case, we calculated the tax separately, but let's try to do it in one chunk instead of doing the separate discount amount. So in the previous chapter in 9.3, we learned how the increase and decrease works. So discount is actually the negative growth. So think about this as a growth rate. So think about as a growth rate. Then you should see that this is actually 5% negative growth or 5% decrease. So here it is R equals to negative 0.05 because it's 5%. And this is in decimal clearly. So the big R, the common ratio, would actually be 1 minus 0.05. So it's 0.95. So to simply find the discounted price from $313, so the discounted price is actually 313 multiplied by 0.95, and that actually is 297.35. So that is actually how much the Apple Watch is after the discount. So what about after the tax? So in this case, in the first store, what we did was we calculated the tax separately by simply multiplying the percentage to the original value. But now let's do it the similar way as the growth rate. So if the growth rate, so in the tax, if it's a 8% growth, this is the same as saying the R is 0.08. And this is also same as saying the common ratio is 1 plus 0.08, and hence it's 1.08. So all you have left to do is simply multiplying, so the total price for the second store is actually 297 multiplied by 1.08. Let me change that to multiply. And plug this into the calculator to find that this is actually $321.14. So now let's compare. So in store 1, even though the starting price, the actual price of the Apple Watch was less, $13 less than the store, how much the store 2 was selling for, you're actually paying more. You're paying $324 as opposed to $321.14 or 14 cents. So, and obviously we can just look at this problem. Yeah, it's obvious because yeah, there's numbers all given to you. But in real life situations, all these numbers may not be as clear or may not be as apparent to you as this problem. So a lot of the times people will fall into that little error and think that they'll actually get better pricing in store one. But in reality, the store two, even though it's only like a little less than $3 discount compared to store one, it is still $3 that you're not paying. So make sure that you know how to do all these. And this is very useful when it comes to real life. Now let's look at a different example. So this is, let's talk about stock market, or because the stock market's changed by percentage and that's all you really hear. You don't really hear the raw numbers going up and down. And actually, let's do something that you may be more familiar with. Let's say the Bitcoin. So suppose the Bitcoin price today is, these are some made up number. I don't know the exact Bitcoin price right now. So let's say it's $10,200. And let's say tomorrow it's $10,700 on the third day. So let's say day 3. Let's say it went to $10,350. So it's not a big difference, but this is just for the sake of the problem. So on day 1 or today, it was $10,200. Tomorrow it was $10,700, and on the third day it was $10,350. So let's do like very small little calculations between each of these numbers. So let's say, let's compare to today to tomorrow. So when we're going from today to tomorrow, we can clearly see that from $10,200 to $10,700 is clearly $500 increase. That's a raw number increase. But how do you know? So, but what's the percentage increase? Or in other words, what's the growth rate? Growth rate. So remember how in growth rates are, we calculated the final value minus the baseline by the baseline. And here we can see that the difference between the $10,700 and the $10,200 is $500. And you're simply dividing it by the baseline, so $10,200. And by putting in the calculator, you should be able to find that this is approximately, I'm saying that approximately because it's a repeating decimal, it should be 4.9. So that is actually 4.9% increase. Now let's look at tomorrow. So let's say day 2 to day 3. excuse me. So the price difference from day 2 to day 3 is $350. But we can see that it's a $350 of decrease. So it's actually minus 350. And to find the growth rate, we can simply do the negative 350 over the baseline. In this case, the baseline is tomorrow because we're going from day 2. So this will be $10,700. And your growth rate is actually approximately negative 0.033. And this actually implies that it's a 3.3% decrease. Let's look at one last relationship. So let's say today to day 3. So when you go from today to day 3, let's compare the numbers. So it went from, we're not talking about tomorrow. We're not talking about the day 2, but comparing to day 1 to day 3, we can see that it increased by $150. So we know that from today to day 3, it is actually $150 of increase. And the growth rate here is the difference, which is 150, and you're dividing it by the baseline, so which in this case is the initial value at the today's rate. And that's actually approximately 0.015, and hence that's only 1.5% increase. Does that make sense? So let's do some recaps. Let's do some recaps and a little definitions. So to express ratio, let's say A over B, where here A and B are different numbers, as a percentage, you simply write the ratio say as a decimal and you simply multiply 100 to it, and that's your percentage. And that's actually what we've been doing. Even in the previous example, what we did here was we changed the fraction or the ratio into decimal, and we simply multiply by 100 to actually convert it to the percentage. The second point, so to express let's say some P, this is a notation for P, this is some number, percent, as a decimal, simply divide P by 100. This is actually the same statement as the previous statement. So you go from decimal to percentage by multiplying 100, and conversely, you go from percentage to decimal by multiplying 100. I mean, dividing 100. That's all what this sentence is saying. So let's say, so to find P% of B, here B is some value, just like the sales amount, and P% will be this tax amount. So 8% of $300 Apple Watch would be an example that we already did. So simply change P to decimal, and let's denote to the smaller p. And multiply to the value. And that's exactly what we did in the previous example, where if you want to find the 8% of $300 Apple Watch, you change the 8% to decimal. So let's denote it the smaller p, and in that case, that was 0.08. And you're multiplying to the value, in this case, was $300, and you found the tax amount by doing that. So the next one is, let's say if you start with a baseline. So let's say if you start with a baseline, it denoted the capital B, and add, let's say, P% to it. You end up with a final value. So you end up with a final value. Let's denote it F as a final value, which is actually 100% plus P% of B. This simply means that if the Apple Watch that you're trying to buy is the baseline, and let's say that's $300, and if you add 8% to it, you're simply saying that the final value is actually 108% of of the baseline, or in respect to the baseline. And if you change all these into decimal again, this is actually exactly the same as saying that the final value is given as, so percentage to decimal will be 1 plus the smaller p. Let me denote the smaller p as putting a little underscore there, just so you can tell the difference between the big P and the smaller p. And you're multiplying it by the baseline. So in the example, we simply did 1.08, which in this case is 1 plus 0.08, and you multiply by $300 to actually find the $324, which is the walkout price of the Apple Watch. So now that we actually created the established the formula, established the equation, let's say, then knowing this is actually the same. It's an equivalent statement to saying that the baseline is simply found by dividing 1 plus p from f. This is achieved simply by dividing 1 plus p on each side. And by simple arithmetic, which I'm not going to go through the details, this is also the same as saying that the percentage in decimal can also be found by simply doing the final value over the baseline minus 1, or this is also the same as saying final value minus baseline over base value. And exactly, you can see that this is what we have used to find the growth rate before. We just had a different notation. We just had y, x, and x, but it's exactly the same thing. Does that make sense? So let's say one more example. Let's do one more example, and let's call it a day. Example. So suppose, let's say 40-inch smart TV was originally $360, but due to Black Friday, it's now $120. Let me put the now 120 up right next to the value. Now it's $120 for the Black Friday. And the sales representative, so the sales representative says that going from $360 to $120 is actually, it's a $200% discount. Let's say that's what the sales representative claimed. And their logic is because $360 is 200% increase from 120. Does that make sense? Or is the sales representative claiming the true statement? Is it true or false? So as you can see, when he claims that $360, so $360 is 200% increase from $120, it is actually in fact a true statement, because you're increasing 200% from here. In other words, So in this case, if you use this formula where the percentage increase from the final value, the baseline, over the baseline, you can simply see the 360 minus 120 divided by 120 is in fact actually 2. So that's actually 200% increase. But you're mixing this up. So this sales representative is actually mixing this up because the statement is dependent on the different base value and different baseline and the different final value. So when the sales representative claims it's a 200% discount, they're actually considering that the $120 is the baseline and the 360 is the final value. But this is not the case. The TV was actually originally $360 and it was discounted to $120. So let's do the calculation. So in this case, it went from the baseline was actually 360 and the final value is $120. So if you actually put that into this little equation, it's actually $120 minus $360 and you're dividing it by 360. And if you use this formula, you can actually end up with negative 0.67, and that's an approximate value. So in this case, this is actually only, not really only, but this implies a 67% discount as opposed to the 200% discount claim, which does not make sense at all. So here, as the same argument with the growth rate applies here, we can see that if you change the location of the final value and the baseline, you'll actually end up with a different percentage or different rate of growth. So in this case, we can take out the fact that it is not symmetric. So make sure when you tackle problems like this, make sure you understand what the baseline is and what the final value is. So I think I'm going to end the class here. But for your exercise, I'm going to give you a little exercise. You don't have to turn this in. Try to do example 10.7 from the textbook. It's a little more advanced example, and if you understand this problem, you're probably set for this chapter. Well, thank you for joining the class, and I hope you have a great rest of the day. I'll see you next class.